Hello, PreCalc. Here we are. It is the class after Wednesday, and after our Wednesday's class you'll be viewing this video sometime. It's the 125 edition. We're going to look at parabolas again. The last video on parabolas. So I'm going to ask you to find the standard form in Sketch. Let me remind you what the standard form is for parabolas. There's two. Well, I guess I didn't give you those two. Let me peek. Alright, so there are two standard form for parabola. There's two of them, and one of them is x minus h quantity squared equals 4p times y minus k. Alright, h is always associated with the x value and k with the y. Hector and Kyle come out to play again. Notice the squared term is x and y is not squared. When that happens, we have a vertical parabola where the opening is up or down. Oh, sorry, I wasn't in the screen there. So this is x minus h squared equals 4p y minus k. That's vertical. The opening is up or down. If p, this whole term, 4p, if it's positive, the opening is up. If it's negative, the opening is downward. Alright, so then if we have the horizontal one, its formula is y minus k quantity squared. We still are associating k with y, but this time the y squared, the y term is squared and the x term is not. That's where we have a horizontal. Here, if 4p is positive, it opens to the right. If 4p is negative, it opens to the left. Alright, so I'm going to ask you to do problems like this, where we take a couple characteristics that are known and come up with standard form and sketch it. Here we know that the vertex is 2, 1 and the focus is 2, 4. So first of all, we're going to look at that. So I'm going to graph it. So you graph it as well. So you can see that when we put 2, 4 here, I mark it as a focus, and 2, 1 here is the vertex. So talking about that, what must this parabola look like? Is it going to be a left, right, up, or down? I can tell because of the relationship between the focus and the vertex. Remember, the vertex is the most extreme point. So in this case, and the focus is always enveloped or shielded, protected by the parabola. So we must have one that goes like this. Do you see how that's the only way? This could be the extreme point, in this case the lowest point, and it envelops the focus. Notice I drew it in very lightly because I don't know how wide the parabola is. So I'm going to borrow from an XY chart, and I'm going to put, well, I'm going to leave that for now. We'll have to sketch it last. I'll come back to the XY chart. If you wrote it there, just leave it. Alright, so now I'm going to come up with standard form. So standard form, I recognize this is going to be a vertical one that opens up. So I'm expecting to use x, move this over. I'm expecting to use x minus h quantity squared equals 4p y minus k. Alright, so now we have x minus h quantity squared. So h, this in vertex is my h and k. It'll go into the formula with the opposite sign. X minus 2 quantity squared equals 4p y minus k, which is 1. Alright, so all I need is P, and I have the complete standard form. And P, you'll recall from yesterday, is the difference between the distance between the vertex and the focus. It's also the distance between the vertex and the directrix, but that is not part of this problem. So this distance is P. So if I find this distance, I can put it in here, multiply it by 4, and be done. So I can look at this. Here I was at the y value of 1. Here I went up to the y value of 4, and the difference is 3. So this distance right here, P equals 3. So I'm going to come back over here. I put in a 3 for P, and then I'll simplify it. 4 times 3 is 12. That's standard form. Now I would like to sketch it. I've already put in the focus and the vertex, but I don't know how wide it is, so it's helpful to come up with some XY values. I'm just going to use 1. Say I'm going to put a value in here in this equation. So say I have the value x equals 0. Alright, so then I get 0 minus 2 squared, so that's 4. Minus 2 squared equals 12 times y minus 1. So to solve that for y, I distribute the 12, and I get 4 equals 12y minus 4. I'm sorry, minus 12. And then I move the 12 over by addition, and I get 12 plus 4, which is 16. And y, divide both sides by 12, I get y equals 16 twelfths, which reduces to 4/3. So, when x is 0, y is 4/3. So here x is 0, y is 4/3, which is 1 1/3, so about right there. So this is a little higher, but not much than the vertex. So we're going to have a really fat parabola. So if there's a point here, there's a mirror point over here, and I go like that. Alright, so I've sketched the parabola and I've found standard form. Sometimes we're going to be told another type of material, like another set of information, and we're going to be asked to do the same thing. Find standard form and sketch the parabola. So I'll do one more. Suppose that we have this information. Trouble getting this in the screen tonight. I don't know why. Alright, it's crooked and everything. So let's say that the focus is known from the second example and the directrix is known. So again, I want the standard form and I want the sketch. So I start out drawing what we've been told. So on a graph I put on the point 2 over and 2 up and call it the focus. And I graph the directrix, which is y equals minus 2. Horizontal line hitting the y-axis at minus 2. Alright, so that's the directrix. And if you recall that the vertex, we need the vertex for standard form. If this is the focus and this is the directrix, once again, we are going to have a parabola that will open upwards because the parabola is going to be enveloped by the focus and it's going to, the directrix, it will not intersect. So it's going to bend away from it. So we have a situation where I'm going to recognize this is a vertical one. X minus h quantity squared equals 4p y minus k. Alright, when I put that in the screen, we'll start putting in what we know. We've got to find h and k, which are the vertex. So I know that right in between, directly in the middle, between the focus and the directrix is the vertex. So if I went up 2 to get to the y value of focus and down 2 to get to the y value of the directrix, you'll see that right in between -2 and 2 is the point right there. And what point is that? It's 2 over and 0 up, 2, 0. So therefore, I know that this is Hector and that's Kyle. X minus 2 quantity squared equals 4p y minus 0. So I won't write in that part. So now all I know is p. Can you find p? From your previous p training, you see that p was the difference between the focus and the vertex right here. So if we were at 0 for the y and we went up 2, this is p. So it's a distance of 2. So I'm going to replace p with 2. So I get x minus 2 quantity squared equals 8y. Now all I need to do to finish that is to go ahead and find one other point on the parabola. So I like to keep it fairly simple. So I'm going to put in x equals 0 and see what y is. So when I do that, I put a 0 for x, I get minus 2 squared, or 4, equals 8y. And when I divide both sides by 8, I get 1/2. And y equals 1/2 when x equals 0. 0, 0, 1/2 doesn't work, because that means it would open down and cross the directrix. Alright, I have to think about this one. What went wrong? Y was 2, x was 2, the h quantity went in as minus 2, 0. The distance between these two was 2. That makes 8. I put in x equals 0. I get minus 2 quantity squared, which is 4. 0 over 1/2 up. So, okay, that works. I'm sorry it takes so long. I guess there is nothing wrong with that. And at first I thought there was. Come back, come back. So here we have the fact that the point 0, 1/2 is on the graph, and I put it on there, and for some reason it didn't hit me as correct. But looking again, I see it's fine. So 0, 1/2, and that is a little higher than the vertex. And so I'll put a mirror point over here, and I can sketch it. Once again, we have a fatty. All right. Very good. So we have sketched the parabola, and we have come up with its equation in standard form. So there could be all kinds of different information that I can give you, but here's an example where I told you the vertex and the focus, and here's an example where I told you the focus and the directrix. The directions were the same. You were able to graph it and come up with standard form. So we'll have a couple of these to do tomorrow, and so hopefully some of the skills that you saw tonight will transfer. So bring them with you. All right, till then, goodbye.